Welcome back to our course on trusses. We are discussing some ideas for trusses. We have our second idea here. Just to enrich our imagination with trusses, we will have some quick calculations, hints and final answers, and you consider the full calculations by your own now. And you have any questions, please submit them and they will be answered. I suggest that you hold the video, go on with your calculations, and then check final answers with our video. We have this truss. We will start by computing reactions. Taking moments about A, we will compute YB to be 3.5 tons. Considering equilibrium in the Y direction, we obtain YA, and considering equilibrium in the X direction, we obtain XA. To get members 1 and 2, we just consider joint F, and it is easy to consider equilibrium in the X direction to get member 1, equilibrium in the Y direction to get member 2, and here we are. Joint E proceeds in the same way, and we get member 3. Note that not all members are marked. We are just enriching our imagination, and therefore we will attack only the marked members. To go to members 4 and 5, we need two equations in two unknowns. Please note that 4 and 5 are forming the K shape but inverted. So we need two equations. Generally, we take one in the X direction and one in the Y direction, maybe considering one joint and the section, whatever you are convenient with in the solution of your truss. Here is joint G, and we consider equilibrium in the Y direction to get a relationship between internal forces in members 4 and 5. Please note, even if you do not need to extract the joint outside, it is good practice to apply the arrows indicating tension force on the link members you are calculating. Of course, if you are having some quick calculations, you can put the arrows correctly, whether they are compression or tension. But here it is much easier to consider tension, force, and proceed with the calculations. We need another equation in the X direction to have another equation in the two unknowns members 4 and 5. Then solving those two equations together, we just get each value of the members. We proceed with our calculations. We consider joint A, and angle theta must be calculated. Please note that in the same truss you may have various inclined members, various inclinations of members. So member 4 makes an angle 45 with the horizontal. Member AD makes angle theta with the horizontal, or member 6 makes angle theta with the horizontal. Tan theta is half. 3/6 half. So we proceed with joint A. It is better, of course, to start with the equilibrium in the X direction, just to have one unknown member 6. Then you can consider the Y direction to get member AC, but we don't need it here. We take section S1, S1, just to compute members 7 and 8. Considering the Y direction, member 3 doesn't appear, member 8 doesn't appear, all horizontal forces do not appear. And we are left with the vertical forces in the cut members. So member 4 will appear in our equation, members 7 and 6. We already computed member 4 from joint G, and we already computed member 6 from joint A. So we have the equation in the y direction with the only unknown, the component of member 7 in the y direction. This gives F7 equals 0. Considering joint C and taking equilibrium in the x direction, we already have members 4 and 7, and the only unknown here is member 8. This gives that member 8 equals 12.5 tons. Tension member. Of course, it is easy now to proceed with any other member. And this concludes our second idea.